Looks like we're live. Hello everyone and welcome to yet another recreational programming session with Azuzin, of course. Let's make a little bit of an announcement and officially start the stream. Hello everyone, welcome. I can see you guys in chat. So let's do the usual red circle live on Twitch. And what are we doing today on Twitch a television website? Today we are doing a better C building tool. How about that? So let's do http twitch.tv/studying, so the place where we do all that. And I'm gonna ping everyone who's interested in getting pinged. I suppose everyone who's interested is actually pinged. All right. So what I want you to do today, I want you to work on my build tool for C, right? So some of you can remember, especially all viewers, this kind of project, right? So the idea of this project is to actually use C to build C projects, right? You should not need anything but a C compiler to build a C project. And I think that main idea kind of makes sense, right? So things like make, CMake, shell, CMD, PowerShell, like other building tools, they are separate things, right? So you already have in your possession a Turing complete programming language, a system one that can interface with the operating system, and since it can interface with the operating system, it can do anything that operating system can offer, right? So it is as powerful as any building tool, right? So it's a little bit verbose, but anyway, it can do anything. So, and why do you need all these complicated separate third-party things to build a C project if you already have a C compiler, right? So since you have a C compiler, you should be able to build everything. So that's where this idea like basically stems from. So we basically implemented a simple library with which you're writing, building recipes. You bootstrap it once and you call this sort of building recipe and it builds the rest of the project, right? Small program, you just bootstrap it with a single compiler call and then call it and it builds everything. Right, so that's the idea. The problem with this project, it really, like, I've been developing and using it for quite some time, like 3 years, right? So it was 3 years ago, and pretty long time ago, relatively. And it feels like it's going nowhere. It feels like it's going nowhere. And I think I recently figured out why. It's not going anywhere. Because I'm doing something with this project that I don't really want to do. I decided that I want to focus on a syntax of the library and make it syntactically as close to shell as possible. Right. And I wanted to do that is because I wanted to appeal to a slightly less experienced C users. Right. So because doing this kind of stuff is kind of a crazy idea. At least 3 years ago, it was kind of a crazy idea. These days, like a lot of people are realizing that, oh, it's actually a pretty good idea to do it like that. Right. Not everyone, but way more than it was 3 years ago. Right, but back then, 3 years ago, it was like a kind of a crazy idea. And then not having like a syntactically nice thing, I felt like it's gonna sound even more crazy than it already is. And I was really insecure about that. And I thought, like, at least let's make it look like something familiar with people, for people. Right. And after all of the mental struggles that I went through for the past 2-3 years, there was a lot of stuff, right? I finally realized I don't give a shit about anyone's opinion. If you don't like the C way of programming, fucking skill issue, don't use this shit, go use Gradle or Maven. Why do I fucking care? Why should I fucking care? I fucking shouldn't. Fuck you. So essentially, I want to kind of abolish this idea of like making C look like shell, and just make it look like a C program, right? Just make it look like a C program. So let me demonstrate you what I mean. So essentially, I wanna use no build from usualizer, right? So, and essentially, how would I write it if I were not afraid to scare away less experienced C users who don't want to program in C anyway? I don't fucking know why I care about that, but anyway, how would I do that? So essentially, let's just basically confabulate. Hallucinate like a GPT model, like what kind of library do we want? I think it's a pretty cool technique that AI actually recently taught us. Just make up shit like a crazy motherfucker and then implement that shit. So I think that's a good idea. I really like that idea. So essentially, in old no build, how would you do that? You would create like CMD, and then you would do clang, W all, W extra, and then you realize like there will be a lot of flags in here. It would be nice to maybe, move them away somewhere. So I would create some sort of a macro C flags. Right, that looks like this, so I can then later just do C flags. Then I would do O, then mutualizer, and stuff like that. And then I'm gonna have some source codes in here and stuff like that. And it's gonna be a huge thing that is very difficult to manage. So some of the things I would probably collapse into macros, right, as I did with the C flags. But some of them are not particularly collapsible because they're not known at compile time. They may not be known at compile time at all, right? For example, the only reason why I managed to put away C flags is because it's a compile time known value. But what if it's not known at compile time? So this kind of approach kind of looks nice for very simple things, but it falls apart when you're trying to do anything complicated. Right, so a proper way of doing that would be to just have a CMD abstraction, right? So basically you have a CMD object, right, and essentially you have a function CMD append, and you're sort of appending things into that CMD. You're just like pushing things into that CMD. Yes, it's a little bit more verbose, but only for those who never programmed in C and have a skill issue, right? So they cannot type or something, right? You know what I'm talking about? It's a little bit verbose, it doesn't look familiar, but this time, after 3 years, I don't really care if it doesn't look familiar to somebody, so I just can do whatever the fuck I want. Right. So, and essentially, you just push these things like that. And you know what's cool about this kind of thing? Is that if you want to sort of like tuck away all of these C flags, you want to tuck away all of the C flags, you can just create a function called C flags, right? And you would accept a pointer to this goddamn CMD, and you would just like copy paste the 7 here, and then you would do C flags CMD. So, and this entire thing basically pushes all of the C flags in here. You see, it's actually pretty cool, isn't it? Right, so, and then you can actually reuse it for different kinds of commands, right? Maybe all of the commands should have the common C flags, right? And before like calling any of these commands, you would call C flags and it will just append all these C flags in here. It looks like Jai. Yeah, it does look like Jai. And you know why Jai pulled it off? Because John is way older and way more experienced than me, so he already doesn't give a shit about people's opinion. I was young, I was naive, I really cared over other people's opinion, and that's why I implemented it in a very stupid way. But John, like, he doesn't give a shit. And that's the right way to do that. That's the right way to do that. Don't give a shit about what other people think. Right. So, yeah, so you're making shit for yourself. Right. So make sure it is comfortable for you. Rest of the people can make shit for themselves. Anyways, right. So you have a C flags. And then you can do CMD append, right? CMD is something like O, and then maybe even mutualizer. So it would be kind of nice to sort of like group related flags and parameters within a single line. And I think this is something we can do. We can make actually CMD append like sort of a variadic thing, right? So essentially it allows you to actually push several of these things. And as far as I know, I think Go's append works like that, right? So can I do not really main, but more of a Go doc append? Does it appear in Go docs? Yeah, the thing about Go docs is that It's super easy to find in things in a standard library, but I don't think append is in a standard library. I think it's like a built-in keyword or something like that. Right, so things like that are kind of difficult to search with Godoc, but maybe I'm doing it wrong. I don't really know. Right, so go append. Right, and the cool thing about append, oh, it's in built-ins. So there is a package called built-in. Okay, I didn't know that. So let me see. Built-ins. It's built-in. It's a single one. Okay, that's very interesting. The append, yeah, okay, thank you so much. So essentially you provide the slice that you plan to modify, and then this is a variadic function, right? So it's a variadic function, you can push things like that, so it's very convenient. I wonder like what other built-ins you can have in here. Okay, thank you very much. I didn't know that it's all in a separate package. There's not that many of them, by the way, surprisingly. I thought there is more. Like for example, go, which is a keyword, right? It's not present in here, so there will be no information about that stuff. But anyway, so we can make CMD append like a variadic thing, and that is very useful for grouping together things like O and mutualizer, because this is a parameter of O. Right, and the next thing I would provide, I probably would provide the source code. And the source code consists of several things like mutualizer C, right? So then plug C, then things like ffmpeg, Linux, and you know where it's all going, right? So all of the source code, it would be kind of nice to also tug them away. And that means we can have another function, right? So mutualizer src, right? So you see, having these functions as sort of like things into which you can fold the parameters is actually very convenient, right? It is extremely convenient. So I can just copy paste this entire stuff in here. I think one of the translation units that we have in here is called separate translation unit for mini audio. It's my favorite translation unit. Yeah, we introduced it in the previous stream. And the reason why we introduced that thing is because it's a hack. Right, so we should not have that, but we do have that. Oh shit, oh fuck, or damn. So I actually made some changes off screen and I forgot to actually fetch them. So let me do that super quick, because in the header I actually put an explanation why I did that. Right, so let me quickly do that. Separate translation unit. I'm going to revert the changes for this entire thing. There we go. Since MediaAudio.h includes Windows.h on Windows, this separate translation unit was specifically created to avoid collisions between symbols from Windows.h and raylib.h. It's a really well-known problem that raylib implements a lot of things that collide with GDI and some other things in Windows.h, and because of that, I just compile all of that in a separate translation unit to avoid this sort of like symbol collisions. The interface of this unit should not depend on anything from any audio to avoid that collisions any further. So basically, it's like one layer of abstraction. So like ideally, these things should not exist. I should not be forced to do that, but I did that, and because of that I made it clear that this is a hack. So the explanation of why it exists is kind of inside of the name, but not fully. I could actually put an entire explanation in the name, like in a very huge name, to make it scream like this is a hack. This is not what meant to be, but I decided not to do that, right? So that's basically how I document my code. Like junior developers document code in comments, senior developers document code with the names of the variables, making them as obnoxious as possible, right? So it is obnoxious but intentionally. Right. So there we go. And of course, yeah, or both, as somebody said in chat, right? Because I still wrote a comment anyway, right? So I just did both, just in case. Right, so we have things like that, and look at that. So Linux, but we have actually two separate translation units, right? So for example, for Windows. For this kind of situation, we can do some cool shit. We can do conditional compilation. If Win32 is defined, include the Windows thingy. Otherwise, do the Linux one. Right, but the Linux one actually can work not only with Linux. It's basically like a POSIX thing, but I haven't renamed it to POSIX. So I think in the future it needs to be renamed to POSIX. Right, so in here we can do mutualizer src, right? So there goes CMD. That's pretty cool. So, and we can continue working like that. So that's actually very interesting. And what's funny is that on different platforms, we need to use different compilers, right? So for example, on the POSIX, we're using Clang, specifically for that build. On Windows, we're using MinGW. And we can also abstract that away by maybe introducing a function, platform compiler. And we're going to provide CMD. Platform compiler, CMD, and in the platform compiler, we can do the following thing. So this can be CMD, right? And again, if we are on Windows, right? So Win32, just use CMD append, CMD. So what was it called? What was it called? It was called this x86-64 W64 MinGW32 GCC. That's right. That's the name of the compiler. That's how you're supposed to name programs on Windows. Jesus fucking Christ. Like, you're supposed to remember that. You're supposed to memorize that. If you don't, are you even a C developer? I don't fucking think so. Like, if you can't memorize that, you're not even a C developer. I'm joking, by the way. Else, and in here, we're gonna just do CMD append. Right, CMD append, CMD clang. And we're gonna just do and if w win32, not wine, but win 32. Do you plan on adding multi-threading? I guess, I mean, you can add multi-threading, but I mean, you make it sound like it's a huge feature and not just include pthread and just start a separate thread. So it's just like, I don't know. And do you really need multi-threading? Because you can just run commands asynchronously. So you can run commands asynchronously and you can just pull their statuses, if that's what you mean. Right. Because like multi-threading inside of the program is only needed when you do the work inside of the program. But in case of a building script, most of the work is done outside. So in that case, you don't really need several threads. You can do everything in a single thread and you can just make a synchronous program. Like, what's the point of multi-threading? Right. So sorry for asking obvious, where is CMD append? That's the neat part. It doesn't fucking exist. That's what I said at the beginning of the stream. Right. So I can show you. Let's try to compile this entire thing. Learn how to program using non-existent libraries. This is actually a very valuable skill if you're going to be designing your own libraries and stuff like that. Like pretend that you're GPT and you're just hallucinating some fucking shit, like insane fucking shit, and just like use library that doesn't exist. Like if I try to compile this entire thing, so it doesn't even have CMD. CMD is not existing thing. There is no such thing as CMD append. Like I just made up that shit. I just made it up. Like it doesn't fucking exist. It's not even a real program. That's the point. That's the whole point. I'm programming in non-existent library to see the flows in API before I even start implementing that shit, so I don't waste time on a shitty API. See what I'm talking about? So before I go ahead and implement this entire shit, I want to make sure that it's pleasant to use. How can I know whether it's pleasant to use? Like I just use it. It doesn't exist. When did it stop me? When did non-existence of a library actually stop me from using it? He's going crazy. Fake user API, yeah, exactly. I mean, so when GPT does that, everyone, oh, it's so cute, it's confabulating shit. When a human does that, oh, he's fucking going crazy. But like, the hypocrisy, the level of hypocrisy is fucking insane. Like GPT can do that, and everyone, oh, can't have bad API if API doesn't exist, exactly. So let's continue. Yes. So and essentially, yeah, we begin platform compiler. We put the C flags, then we do the output from visualizer, then visualizer source code. And the last thing we need to do, we need to actually put the link with the libraries, right? So we need to put with the libraries, link libraries or something like that. So, and essentially I'm filling up the command not with individual flags, but with chunks that can work differently depending on the platform we're working with, right? So I'm not thinking in terms of arguments. I'm thinking about these sort of blocks that I factored out, right? So then I can have link libraries. So, and in here, we're gonna do something like CMD, and essentially all of that could be different depending on the platform as well, right? So we'll see how it can go. So this is going to be append. We'll put CMD in here. And by the way, in all of these cases, when we do CMD append, we shouldn't really do that by a pointer because CMD is already passed by a pointer. So I think I need to quickly query replace that without the pointer, right? So something like this. And this is where sort of like an auto referencing feature of JAI is actually very useful, right? So I think it would automatically like remove this kind of thing or something. I don't really know. But anyway, so CMD append, and here we will just do, yeah. You know what would be cool? Actually, it would be cool to be able to call to package config, get its output, and use that output as the arguments, because that's how package config actually works, right? So you do package config, you do cflags arraylib, right? You do cflags arraylib, and of course it doesn't work because we need to set up arraylib development environment, otherwise it's not going to work. Permission denied. Oh, because this is how you're supposed to do that. There we go. So you're supposed to do it like that. So you know what, for now I kind of want to hard code this entire things, right? So where are cflags, right? So in here we're gonna have cflags like so, right? So this is that. And by the way, we can discriminate by the operating system, right? So for Win32, we're going to use the include that is located locally. So I already have like arraylib downloaded in here. So I can just like use stuff from that thing specifically for Windows. And as I finish this entire thing, I think I'll be able to unhard code it. Right. So because of that, this is Windows. Otherwise, it's that. And if Windows. There we go. So, and similarly, we want to do the stuff for link libraries, right? So in here, so if it's a Windows, it's L, but it's lib, and if it's Linux, it's lib in here. There we go. So that's pretty cool. So, and on Windows, if I'm not mistaken, you also link with a bunch of things in here, right? So arraylib, win, and static and stuff like that. So CMD append, so this is CMD, and let's just put them like that. So this is how basically I want the no build to look like, right? Roughly. So here, where is the POSIX build? So there's a couple of stuff in here. So I suppose the most important thing you have to link with is arraylib itself, right? Plus the usual thing, mathematical library. Yeah, there we go. Mathematical library, dynamic stuff, and pthreads. So the usual things. Yep. So, and after that, okay, so we basically constructed you know, the command line for building the single thing, for building visualizer, and then we do CMD run of that command, maybe even by pointer. Maybe pointer is not actually required in here because CMD run probably not going to modify CMD, or maybe it will. I don't really know. Right, and then maybe CMD run is supposed to return the exit code of that command, and for example, if it's not equal to 0, we're going to return non-zero exit code, and we're going to hope that the error is going to be reported by this entire thing, and that's it. So that's basically it. So this is how I want this thing to work, essentially. Right, so you can create CMDs and stuff like that, and just work with that. So interestingly, as already said, it would be nice to have some sort of an integration with package config, right? Package config, right? And you would do maybe, so you would get strings or maybe some sort of like lines essentially some sort of a structure that contains like, you know, the lines of the output of package config. And then you would provide the package name, right? So this is going to be the package name. And what exactly do you want from it? C flags or not C flags? It's actually a very interesting question. What kind of flags can you have in package config? There's a lot of flags, but the primary one are C flags and libs and stuff like that. So yeah, so maybe it's going to be enumeration, but at the same time, they're more like a masks, if I'm not mistaken. Right, they're more like a mask, so C flags and libs. So I need to come up with a name for this thing. Would you even call these things? How would you even call the preprocessor compiler flags? Maybe we could call it something like unsigned int flags, right? And essentially you would have C flags, which is 1, and libs, which is 2, which are essentially in binary notation 0, 1, and then 0, 2, 1, 0, right? And then you would use it like this, package config C flags, and then package raylib, or C flags and libs, something like that. Right, so something like that. So, and it should return these sort of lines that you can then append to your CMD or something, right? So, but it's not gonna really work like that because append expects the string, it accepts the string, so maybe append like lines or something like this. And of course, package config may fail, so it also has to be handled like that. So maybe we could do something like this. If it's basically failed, we return 0, but then you can have line args, which is essentially passed by a pointer, and then you put it like that. So something like this. If you want to work with package config, right, so you can call it. And inside, package config is implemented in terms of the same CMD thingy. It's implemented in terms of the same CMD thingy, where you just do CMD, package config, and so on and so forth. You see what I'm talking about? Right. So basically you have very basic, like low-level abstraction of calling, you know, external command that is implemented for both Windows and Linux. And then you build additional tools on top, like integration with package config and stuff like that. So you need GCC and package config. You need GCC 100%. Package config is not really necessary. It's more of an optional dependency, but in some platforms it's convenient to have, so I don't really mind that. Right, C compiler is going to be needed like anyway. It's going to be needed anyway. So yeah, so that's basically like a rough idea. That's basically a rough idea. But I'm not gonna go into package config right now. This is sort of like a, you know, the rough sketch of how I want it to work, right? So of course this is not implemented, right? So it's gonna go like this. And yeah, we already established that this is gonna be something like this. You pass it by reference or something like that. Redirecting the output and collecting the output is also an interesting topic, I think. Right, I think it's also an interesting topic. We already done that. No build is already capable of redirecting output and stuff like that, but collecting it into sort of like a separate structure and then pushing it into the command line arguments, I think it's kind of cool to implement. Package config is only cumbersome to bootstrap because guess who its dependency specify their dependency. Yeah, exactly. That's why I probably not gonna use package config in the future. But that's just something to keep in mind. Like if you need that, it should be possible to implement that in no build, right? So essentially, no build is supposed to be just a tool, right? Just a tool should not stay in your way even if you have a bad taste in things. You know what I'm talking about? It's not the tool's responsibility to develop your taste. The point of tool is to solve problems. If you have a bad taste and you want to do package config, like sure, why not? You can do that. So I'm not here to, you know, educate you or anything like that. So I'm here to solve problems. Okay, guys, so I suppose that is basically it. Interestingly, so maybe CMD run is not gonna really accept any additional things. Things like CMD run should also probably accept parameters that allow you to redirect the standard output. For instance, maybe we could have like a string builder, right? So string builder, we can say that this is std out, right? So this is std out, and CMD run on top of accepting CMD, right? It returns code, right? It returns an actual code, but it also accepts string builder std out, right? And the output could be just string view, right? So this is your standard input, and it's also by a pointer. Right, and if you want to have the default standard input, you just say, okay, this is null, but then I want to collect the standard output, so I provide this string builder, and then at the end in here, I have this string builder that basically contains all of that stuff in here, so I can basically collect all the output. And this is, by the way, the mechanism that could be used by the package config implementation, right? So it's called the package config, it collects its output, and then parses that output, splits by a line, and it returns you these split lines. And then just returns you split lines that you can then push into the CMD and call further and further and further. So this is basically how it's probably gonna go. Right, and essentially this tool is also going to provide the usual things to work with dynamic arrays, right? So the usual DA append macro is going to be here. My favorite abstraction of string builder, as already mentioned, is also going to be here. We're probably going to have string views. We're probably going to have arenas. So like all of the allocation is going to happen in the controllable places and stuff like that. So we'll see. Oh, this is for Windows. This is for both Linux and Windows, and probably for macOS as well. So I would say I'm targeting both POSIX and Windows, which includes Linux and macOS. Right, so that's basically the idea. So let's go ahead and try to implement all of these things. So what we're gonna have inside of CMD, right? So what's gonna be the CMD? CMD is supposed to be some sort of like a dynamic array. Wait a second. Don't I already have a CMD structure somewhere in the no build? I think I already have something like, you know, CMD in the no build. So let me actually download it. Can I, maybe I don't have to rewrite no build from like completely from scratch. Maybe I can just like slowly migrate out of the shell-like syntax to what I actually want. Maybe that's what I can do. That would have been actually super poggers, I think. Right, so don't I have... Okay, so there is already CMD, so it's sort of like hidden. I think I already had that idea back then. So, but it uses sister array. And what is a sister array? So is it dynamic? Okay, so here's the main problem. It's not a dynamic array. Like I expected this thing to be a dynamic array. So a dynamic array also has like a capacity, right? So it basically allocates more elements that it's going to use. But the way I work with that is actually kind of stupid. It's more of like a functional way. Yeah. So it doesn't even modify the string array. Yeah, so the append that we have in here doesn't even modify. It just like creates a new one and mallocs a new one every time. And the reason why I did that is because to make it work, to make it feel like a functional thing. You're not modifying the array, you're creating a new one, so the links, the pointers to the previous ones still exist and they're still valid. And I do a lot of mallocs in here and never free them, because the build tool is supposed to be like a batch tool, which means that when it exits, it's going to deallocate all of its memory like simultaneously. It doesn't really matter. So yeah, but I don't want it to be like that. I want it to be more like a, how to say that, stateful, right? So I want to have sister array append to pass it by pointer, right? I wanted to pass it by pointer and not return anything. Yeah, so I think I'm still gonna start from scratch and maybe see how I can extend existing version of no build to preserve maybe backward compatibility or something like that. So we'll see. So okay, so this is a CMD. We can gonna have args, and it has to be a double pointer, right? Because it's an array of strings. Here we're going to have a count, and here we're going to have a capacity, right? Capacity. There we go. So it's a classical dynamic array. It is a classical dynamic array. So for a classical dynamic array, we need to have a dynamic array DA push. We need to be able to push into dynamic array. So this is going to be command.h. So DA append, here it is. So here is the thing that allows you to push in here, right? So, and the question is, how are we going to implement CMD append, right? So we're gonna accept CMD, and I think this is a very difficult thing, because we don't know where to stop, right? Do you guys know what's the main problem with C variadics? So it's like the most annoying problem with C variadic is that they don't provide a mechanism to know when to stop handling the arguments. You literally don't know. And that's annoying, because here I made some sort of an assumption, right? I made some sort of an assumption that we don't have to provide the amount of arguments. So the usual thing is that you either provide the amount of arguments in here, which is stupid and really error prone, or you provide the null in here. And the null is also stupid because you keep forgetting this kind of null. You keep forgetting it. So probably we'll have to have a separate implementation. So something like CMD append null, right? And then we're going to have CMD append macro that accepts CMD and variadic parameters. And macro actually allows you to not provide any amount of arguments or anything like that. So the way you do that, you just call back to this thing, you do CMD, then you call VA args, which effectively expands to all of the arguments you provided in here. It expands to all of the arguments you provided in here, and then you additionally put null in here. So that's how you're supposed to solve that in C. Welcome to C, I suppose. I don't know why we're still programming in this language after 50 years. Right, so half of a century old language, we still haven't come up with anything that is better. I can already hear. But so, what about C++? What about Rust? What about Zig? We have not come up with anything better after 50 years. Trust me. If you think we did, well, you're living in a hallucinated GPT world. I'm sorry to tell you that. Anyway, Fortran. Yes, of course. Yeah, that's the real contestant to see, actually, unironically. Seriously, Fortran. Fortran. Anyways, so we need to now start handling this entire thing. Let me see how to do that. Like, I don't remember how to work with variadics in C. So I suppose you have to do std args first of all, right? So you do std args. You know, let's actually make sure that this entire scheisse compiles. Right, let's make sure this entire scheisse compiles. We already created the append null. We can also provide CMD run and also stub it. Let's just make sure that the stubs work. So in CMD run, we can return -1, right, to indicate an error. So here, we're not going to go into like redirecting standard input, standard output. So let's just keep it simple. Let's just keep it simple. And there we go. So this entire thing should already compile. So this is the answer to the person who asked what is CMD append and where it is defined. Here, that's the definition. So does it answer your question? So this is where it is defined, right? This is where it is defined. You're welcome. I finally revealed. It's a big reveal how all these functions are implemented. Anyways, so let's try to compile this entire thing. So it's going to be clang no build.c, and we don't have a string builder, so that doesn't matter. So a boom, and it compiles. first try. I wrote a code that uses non-existent library, and then in a couple of minutes, I just compiled it, even though the library doesn't exist. Anyways, can your Rust do that? Can you in Rust just confabulate some shit with a non-existent library and then compile it? Just compile it. Like, I pulled this entire shit out of my ass right on the stream and compiled it. Anyways, that's pretty cool. Now, we need to, I suppose, include std args. Right, so we're creating std args. I think it's just std arg. It is in fact just std arg, just std arg. So essentially, the variadic arguments are stored in so-called VA lists. I suppose it's a variadic argument list or whatever the fuck it is. I didn't come up with this name. I think it's just called VA list. Right, there we go. So the next thing you have to do, you have to specify after which argument, non-variadic argument, the variadic arguments come. I think you have to do that with VA start or VA begin or like something like that. I don't remember. I hope the compiler is going to tell me. So you say CMD and you provide the args. So the first argument is basically like after which argument comes the variadic arguments, and then basically the list itself. And this list is going to represent these variadic arguments. So let's try to compile that and see if I was right. Right, so I actually was not correct. I think it's the other way around. Yes, very intuitive, I know. So it's actually the other way around. First comes the list and then CMD. At least I guessed the name of this function correctly, because sometimes I call it VA begin. And the reason why I call it VA begin is because at the end of working with variadic functions, you're supposed to say VA end. Args. English is not my first language. English is not my first language, but I feel like the opposite of end is begin. The opposite of start is finish. So if it's called start, I would call it finish. Or maybe stop. Yeah, I think something like stop would have been better. But if you call it end, maybe it should be begin? I don't know, like, again, English is not my first language, so I don't fucking know what I'm talking about. So it's kind of like probably the reason why I want to call it begin is because one of my first languages was Pascal, and because of that I feel like the opposite of end is begin. That's probably why. That's probably why. I don't know. Actually, Pascal is my third language. Yeah, Pascal is my third language. My first language was the scripting language of maps of Warcraft 3. The second language was Visual Basic 6, and Pascal was only the third language. So that's right. That's how old I am. Anyways, so and between these operational brackets, as we call it in Russian, so yeah, so what's funny is that in Russian language we have like a name for these kind of things, for curly braces or for things that you like surround, for blocks, right? For blocks, we call them brackets, we call them operational brackets. So, and between these sort of like operational brackets, you're supposed to work with arguments. You're supposed to sort of pull them. I think you do VA arg, right? And essentially you do it like that. But as far as I know, VA arg doesn't know shit about the type of the argument you provided in there. So at that specific point, at the runtime, at the freaking runtime, you must know what type you pass in there. You must know it, and you're supposed to cast to this type like this. And you've got yourself an argument, the first ever argument. That's it. That's everything you have to explore the variadic arguments the user has provided. You can basically get them, you can get the next one. You don't get the type of that argument. No. You don't get it. You must know it at runtime. If you don't know it at runtime, seg fault. Sorry. Uwu. So, yeah. Oh yeah, so var_arg takes the type as the second parameter. Yeah, I forgot about that. Right, you see, like, I've been using C for quite some time. I still cannot fucking remember how to use the variadic arguments because they suck. They fucking suck. Like, even if you are experienced developer, if you've been even doing it for quite some time, they fucking suck because you keep forgetting, it's confusing, it's just like, why is it like that? Anyway, I'm sorry. So, and that's why, like, everyone says that any language with variadic is already an improvement over C because the bar is so fucking low. Like, I don't know how can you make variadics worse than that. It's the worst variadic implementation, like, in all of the languages. Anyway. And essentially, this is why you have to sort of provide the null, because, like, you don't know where to stop polling the arguments. So, essentially, you can say while arg not equal to null, right? While arg not equal to null, you basically want to push, right? So, probably want to do cmd, just da append, right? So, we're going to do da append cmd arg. So, we're just pushing this entire thing in here. And then we want to poll the next argument. And that's basically it, believe it or not, minor friend. That's basically it. That's basically it. So, yeah, let's see if we manage to implement that. So it doesn't compile because it doesn't like da append, because the da append didn't implement, doesn't see da init, right? So this is the size, the initial size of the dynamic array. So let's actually set it to 156, whatever, just like a random size I pulled out of my ass yet again. What else? So items, oh yeah, this is because the args has to be called items because that's what this macro expects. That's what it expects. What else do you want in here? So it wants realloc. So to have realloc, you need to have stdlib. And what else do we need in here? It wants assert, so let's actually also include assert. There we go. We managed to build this entire thing. So I actually want to build this entire thing with, you know, debug information. So then later I can do software, actually, software gf2, no build, boom. And let's break on cmd run. And let's just straight up run it. There we go. So after that, so we are getting cmd. So we just constructed cmd and we got it as an argument in here. So let's take a look what's inside of it. So here we have 16 elements, right? And the first element is actually clang. And I wonder how can we display all of these elements? Can we do something like cmd items? But on top of that, we probably want to dereference it and then say, okay, display the count amount of elements of that array. And let's see what kind of arguments do we have in here. So here are all of the arguments that we managed to collect throughout the execution of the program. Clang, WL, WExtra, GDB. So this is the Linux specifically, OM, usualizer, blah, blah, blah. There we go. So as you can see, everything working as expected. Everything working as expected. We can see that in the debugger. Straight in the debugger. Isn't that cool? Chat. Chat, where are poggers in the chat? I don't see the poggers in the chat. So yeah, so we can clearly see that we did everything correctly. So the only thing that is left in here is to just basically pass that to exec and literally execute that command. Just literally execute that command and we'll be able to build this entire thing. So I already see the problem, right? So this thing has to be actually built, right? So people are pogging, people already are pogging in the chat. I really appreciate it. Thank you for the poggers. Thank you for the poggers. Okay, so let me see. So here we're supposed to have build visualizer. There we go. So, and on top of that, this entire thing can be also moved away to a separate function. right, to a separate function. So it all can be abstracted away because we're programming in a real programming language, and all of that is going to be compatible with a lot of platforms, right? Because it's C. So there are implementations of C for pretty much any platform, literally any platform. Okay, so how are we gonna implement all of that? Well, we already had implementations of CMD run, I think. So I think it's a CMD run async. And yeah, we already know how to do that for Windows, as you can see. So this is starting the process for Windows. And here, this is how you start the process for Linux, right? So this is how we started for Linux. So maybe we should implement first something like CMD run async, which actually returns you like a PID, right? So it returns you a PID. Yep. So I think we have abstraction that is essentially if not defined. So if defined win32 type def int as a PID, and otherwise if it's POSIX system, well, I mean it's the other way around. If it's Windows system, it has to be a handle. There we go. Now we do end if win32. There we go. So we just return the PID, and yep. So is count syntax GF specific, or this is GDB, right? As far as I know, like all of these tricks with syntax and stuff like that, all of that is GDB. So essentially, I don't think GF even parses anything you put in that watch window. It just like passes the entire string to GDB and just returns the result. All right, so one of the things I would like to have actually, I would like to be able to report, to at least to render the command that we've got in here, right? So CMD show, maybe I can actually steal some of the stuff in here. CMD show, yeah, there we go. Oh, we're just joining all of these things with a space. And to be able to actually join it properly, we need to have some sort of like a string builder, right? So essentially, you can see that the CMD is a dynamic array, right? It is a dynamic array, and it uses this macro. And this macro, as you can see, it doesn't care about the specific type into which it's pushing things. It only cares about the fields of the structure. If the structure has count, capacity, and items, it can push shit into that structure. It doesn't care about the specific type. So that's the beauty of this. And I think it's sort of like a template, but in C, right? So it's a C style of templates. And you can, for example, make a similar structure, the element of which is essentially just a single character, right? So it's essentially a dynamic array of characters, and this is what I like to call string builder, right? So you can push characters in it, and you basically have a string, like a continuous string. And that way, this particular abstraction is actually very useful. You can use di append on it. You can literally use di append on it, but then it is useful for things. For example, you have a CMD, but you want to then display it for the user. So you would have something like CMD render, you accept CMD, and you accept string builder as a pointer, right? So render. And essentially what this thing is going to do, it's going to iterate through the commands and then push them into string builder, concatenate everything, and then you can display it as you want, right? Then you can display it as you want. You can then display them as you want, but just pushing character by character is not particularly convenient. I think it is not particularly convenient, and because of that, I have some special macros that kind of help me with that. So for example, a thing that can push like an entire buffer, right? So SB append buffer, or SB append sister, right? So string, and also SB append null. Oh, you can't really see that, but yeah, now you can see that. It's useful for turning string builder into string array, into C string. Right, so null terminated one into null terminated one. So yeah, actually I already streamed for 1 hour. I'd like to make a small break. I would like to refill my cup of tea. Right, and after the break we're gonna continue working on this thing, and we're gonna implement the rendering of the thing. And I think rendering is very important because we need to be able to log what is going on to the user, right? So it's really important to tell the user what the fuck is going on, otherwise the user gets really anxious and start pressing Control-C without knowing what the fuck is going on, so we don't want that to happen. So we need to implement that. So anyway, let's make some break. Alright, so let's go, meine Freunde, let's go. So one of the things we need to be able to do, we need to be able to append not only a single thing into a dynamic array. So this thing appends only one thing into a dynamic array. We need to be able to append many things. Right, and for that we need to steal yet another macro that I use all the time. It's called the append many. There we go. So essentially it accepts the pointer to an array of items that you want to push and the amount of items. Right, and this is something that we can use to append like buffers into string builder, right? So in a string builder we'll be able to do things like so, right? String builder SB, so we're gonna zero initialize it, and then we can do di append many, so SB something like hello, right? So 5 elements, and this is how you would push 5 elements into that string builder. And the cool thing is that it works not only with string builders, it will work with command lines as well, right? So, which is going to be super useful in the future, in the sense that if you manage to collect a bunch of arguments, right, then you'll be able to push those arguments like this. Yeah. All of the pieces sort of like come together. I really like that. So, I feel like with every C project, I keep re-implementing some sort of my own alternative standard C library that standard C keeps lacking, right? So I keep re-implementing things like dynamic arrays, string builders, string views, and memory arenas and stuff like that. It would be nice if just C came with all of these things. It would be really nice, but unfortunately C is an old ass language and the committee doesn't give a shit about making it better. Right, so what was the latest feature C committee is going to introduce? What's the latest feature? They're going to introduce something actually useful. Somebody said that I already have CSTD in your GitHub. Somebody cannot distinguish C and C++. Do you also think that Java and JavaScript are the same language? Really? So I have a standard library for C++, not for C. Don't confuse them. Don't you dare saying that C and C++ is the same. Did you really say that? That's a very dangerous thing to say, actually. Even in front of both C and C++ developers saying that C and C++ are the same, it's a very fucking dangerous thing to say. Don't fucking say that. It's like saying that Java and JavaScript are the same language. Do you want to start a war or something? Holy shit. Anyway, so we need to have di append many, and this is very useful for string builders, right? So on top of this di append many, we're going to implement SB append. It's a very unnecessary macro, but just for the consistency of the prefix, I like to have it anyway. Right, so then we can have append sister, which just uses append many. But before it uses it, first computes the length of the sister and then just uses the append many. So you see how we use that? Yeah, so that's basically what it is. It's a very specific to string builder, right? And that's why I have SB append buffer for the consistency of the prefix, even though it's backward compatible with the append. Nothing particularly special. And also I have a conversion to string view, but it doesn't really matter. Append null is a very useful thing. So essentially it just appends 0 byte at the end of the buffer, making it null terminated, right? So you can build string builder and then you can append null at the end of it and say, okay, so this is a null terminated string. Now I can pass it to, for example, fopen, right? Because fopen only accepts null terminated strings, right? And if you're building up the path, right, it's very, very useful. So anyway, so essentially what we can do in here, we can start to iterate the items in here. We can start to iterate items. And by the way, recently, I don't think I published it anywhere. I don't think I published it anywhere, but I recently came up with yet another cool macro for dynamic arrays and stuff like that. And that macro is called, I think, DA for each. Guess what it does? Guess what it does? So I don't remember how to implement it, but it allows you to just like do for each on the dynamic arrays of this specific structure, right? If you have a structure that has items count and capacity, you would be able to do for each on them. If I remember correctly, you do it like this, for each. Then you have to provide the type, right? We're going to be iterating the, strings. Then this is going to be arg cmd. Right, and inside of this entire thing, arg is going to be actually a pointer to the elements of CMD, right? So this entire thing can only be iterated by pointers, right? So let's actually put this thing like this: this item set. How are we going to implement all of that? So essentially, we're going to start by defining an iterator. We're going to start by defining an iterator. The name of the iterator is going to be the item, right? So this is the name of this thing. So it's going to be type, and it's going to be pointed to that specific type, which makes it super easy to just do items. So let's not call it items. Let's call it DA, because items is a thing inside of DA, right? Like so. So that's basically an iterator. And essentially, we keep iterating while items is less than DA items plus DA count. Right. And after that, we can do items plus plus. Can you see shit, by the way? I don't, yeah, you can see. And that's it. That's basically the iterator. That's basically the iterator. And that allows us to, allows you to do some interesting things. For example, you can do SB append sister, right? So we know that they are string null terminated things, right? So we know that they are null terminated strings, so we can essentially do render arg, but we have to dereference it like that. And at the end, it would probably make sense to maybe even put a little bit of a space. And there we go, we just managed to render this entire thing. Oh yeah. Ma for each. Right, so the mini audio has a ma prefix, so we have a da prefix. Да, блядь. Да — это for each. Да append. Sorry. Anyway, and if we want to log this entire thing, right, when we're especially executing or something like that, so I think cmd run sync. Let's go ahead and comment it out. Right, let's go ahead and comment it out. It's going to be something like this. 0, like so. And we can do cmd render. So this is cmd and yeah, render, maybe just SB, like so. It has to be like this. String builder, right? So SB, we're rendering it like that. And then we can maybe SB append null, right? SB append null. And essentially we can just print this entire thing, right? So let's say cmd run sync s SB items, not item plus plus, but items. There we go. So yeah, we have a command, we render it into string builder, and after that we can do things like free, for instance. So we can free that specific builder. So, and let's see if this thing is going to work. It doesn't compile, so let's go to the compilation errors. Da for each didn't work. I wonder why. This is because, oh yeah, so essentially I assume that DA is going to be a pointer. I don't really know why I assume that. Maybe it makes sense to actually assume it as a pointer, so you think of it as a pointer. Right. So maybe that's a good idea. So what's the next thing? So it macro expansion. Oh yeah, all right. So essentially we have to wrap DAs with parentheses, right? We have to wrap DAs with parentheses. What else do we have in here? SB append sister implicit declaration. So don't you see implicit declaration of strlen? We just need to include some stuff in here, specifically string. So a boom. Anything else? So implicit declaration of cmd run. So this is because it's called sync. Right. So yeah, this one is a little bit weird because it's more of a sync is supposed to just return boolean, I presume, actually. So it would be better to do it like that. I haven't decided what exactly it should return. We'll see. But anyway. So if I try to run no build now, it should print the command line that we built. So, but it doesn't like that we don't have std boolean, right? And it's segfaulted. Yes, it's segfaulted. Welcome to C, motherfuckers. Welcome to C. Oh. So, but segfault, people may say, oh no, with segfault, it's so scary. But actually, it's just like exception in any language. Right, so if it's segfaulted, that means it touched the memory that it's not supposed to touch. Through a debugger, you can actually know where exactly that happened. Right, so let's actually go ahead and try to do that. I'm going to start the debugger, gf2, and this is going to be no build. You will see it's nothing to cry about. I'm going to just like run this entire thing, and as you can see, we know instantly the stack trace where this motherfucker failed. Okay, so it failed in here. It failed specifically in here. So, and the question is why it failed in here. So it tries to touch a very weird address, which is kind of strange. So we know for a fact, can we take a look in like inside of CMD? All right, so inside of CMD, everything is fine. So what could be wrong in here? Why dereferencing this entire thing? Because I made this like an additional pointer type, which fits perfectly for the items. So I would expect item to be less than plus count, so that should work as well. And then I keep iterating. Maybe we can take a look at maybe a render and see maybe it has more items. It actually has a lot of items. So maybe the problem, yeah. When I was trying to, oh yeah, I know what's the problem here. Right, the problem here is that SB is not null terminated, zero initialized. Right, so essentially it contains the garbage from the stack. So that's the problem here. So that was relatively easy to figure out with a debugger. Debugger wugger. Nothing to cry about. Right, you see, it was not scary. It was not scary at all. Just zero initialize that big. Just zero initialize it. There we go. So put A in here, and look, it works. It works. Nothing to cry about. Calm down, chat. Calm down. It fucking works. Right. So we managed to render this entire thing. But there could be some problems. For instance, I can do cmd append, and I can append a thing that contains spaces. Full bar buzz dot c. Maybe that's literally the name of a file. But if I try to render this thing, it makes it feel like these are separate components, which is not correct, which is confusing, which is misleading. So we need to somehow wrap each individual argument into quotes, but we don't want to actually wrap everything because this thing will become unreadable. We only want to wrap things that contain special sort of characters. Right, and I think I already done something like that in some other project, but I don't remember how exactly I did that. I think Marcut does something like this. It's actually so cool. I've done so many projects. Every time I want to do something, like I know that I've already done something like that in some other project. I just go there and copy paste it from there. Right, I have so many places to copy paste things from. Right, so cmd, I think it's, yeah, there we go. Oh, right. Oh, I think Yeah, so essentially I put a space in here. So basically if the string contains a space, I wrap it in parentheses if it doesn't contain space. Maybe that's fine for now. Maybe that's fine for now. Because you probably want to wrap in parentheses even if it contains more. I think I have a thing in Porth. Yeah, I think I have a thing in Porth somewhere in a standard library. So maybe, so the function, if I remember correctly, was something like proc escape, right? So shell escape, yeah, it's a shell escape. And essentially, it's where it is used. So we do that, and we always shell escape. Okay, that's a very cool thing. Shell save string, shell save character. Okay, so this is how we do that. So if this string contains any of these characters, it is considered unsafe shell string. And we have to wrap it in parentheses or something like that, right? And wrap it in single quotes, actually. And if it contains quotes, those quotes needs to be, they need to be escaped as well. Right, so we can basically steal that information from Porth. So we can steal that information from Porth. So let's quickly do that. So CMD render, where is the CMD render? So it's going to be shell safe is shell safe. We're going to provide the character like so. So const char unsafe. Yeah, let's call them unsafe. Just unsafe. Just unsafe. And I suppose while unsafe is not equal to 0, if unsafe equal to x, so it's instantly false, and we also want to do unsafe plus 1. Otherwise, it is safe. So we went through all of these things. And we didn't encounter any unsafe characters, so it's totally fine. So, and now, what we want to do, maybe we can introduce something like shell escape, which is going to accept the sister, but it's going to output to string builder. That's a very cool idea, chat. You know why? Because instead of appending it like that, I can shell escape it, like so. But the argument, the order of the arguments is different here. Okay, so it's like appending it, but this one is shell escaping. And essentially, if is shell safe, we just, you know, we're just printing it as it is. We're just appending it as it is. If it's unsafe, we essentially wrap in single quotes, but if inside of there is any single quotes, we are escaping those quotes. This actually makes a lot of sense. Okay, so if shell safe, we need to separate this thing, shell safe character, and we need to introduce something like is shell safe sister, where we're going to accept this sister. Right, so this is going to be sister. Right, so maybe also sister. So when essentially while sister not equal to 0, if not is shell safe. Interestingly, space is not considered to be that unsafe, which is really weird to me. Why is it not considered safe? Huh. Maybe I just missed something. So this is going to be sister, right? If it's not, it's instantly false, right? And then this is going to be sister, like plus plus or plus 1. And then like this. If is shell safe sister, like this. If it is totally safe, we want to do SB append sister SB sister. There we go. So if it is not safe, we can just do sb append sister sb. Actually, we can just do a single da append, and we can append a single this thing, and between them we can append that. So the question, does this work with Unicode characters? It works with UTF-8. But this is a good idea for this scenario. Slash is also considered unsafe. To be fair, safe and unsafe in this specific context is a very arbitrary idea. I should have probably not used this word because it invoked and triggered some memory of some people. We're just displaying it on the screen, okay? We're not passing it anywhere, we're not executing it. We're just wanting to display it to the user so it makes sense to the user, okay? So it's whatever, right? I should probably not even... Yeah, so you know what? I'm gonna just check whether it contains space or not, right? So is there something like str... What was the str or strch? Yeah, I think it's strchr. Locate string, yeah, there we go. So this is what we can use, essentially. There we go. To escape string. System. And so if it's safe, we're gonna do that. Otherwise, we're gonna just do that. Okay, so that's it. That's good enough, right? So don't stress about it too much. So this shall escape. So shall escape system. All right. So it's the other way around apparently. So there we go. So this thing is wrapped in quotes. This thing is wrapped in quotes, and that's good enough. So let's go back to implementing cmd run async, right? So let's just go back to implementing cmd run async. And essentially here, what we're doing, right, we need to report an error. So for now, I don't really plan to have like a special logging thingy, but maybe I should. Right, and this is going to be string builder sb. And what we want to do, we want to display. To be fair, yeah, so I think I do need to display. So this is going to be cmd render, cmd sb. And after that, sb append null, sb like so, sb items, str error, and we have to return like a false, right? So in no build, this is another sort of like a ideological change that I want to introduce in no build. Instead of instantly crashing, I think I'm gonna just return and let the user decide whether they want to crash or not. I'm gonna just log the error, right? And in here, right, in this specific case, right, you make a decision how you want to react to this kind of thing. And you don't really need to log anything, right? The specific error is already logged inside. It's already logged inside, so you don't have to worry about that stuff. Okay, guys, so this one is just fprintf. Could not set up a student for child process. So maybe one of the things we need to do, we need to just log, you know, the commands. So this is going to be just cmd. You know what, let's actually log everything into std error, so it's logged into a single stream that you can redirect. I don't think we need anything else in here, right? So this is a cmd, and this is sb items. So this is error, return, error. So let's not do that. So this is gonna be new line. Fprintf error new line. It's kind of like funny how this is an arbitrary decision which I made, whether to display the command line or not display command line, because I can just display it once in here and I don't really need to display it in error messages. I don't know, like when I was developing you know, no build back then, I was not particularly that experienced, so I was just doing random stupid shit. So I think now I'm a little bit more experienced, hopefully. I don't freaking know, honestly. It's kind of hard to tell. Maybe I'm not. Maybe I'm not that experienced. And this one is actually, I said it's synchronous. It's actually need to be asynchronous. And since it's asynchronous, it needs to return PID, right? It needs to return PID. But because it may fail, you have to be super careful with this kind of stuff. And the PID can be different thing depending on the platform. So that's a bummer. So that's a bummer. So how can be, because depending on the platform, the invalid PID is different, right? So in case of Windows, it's going to be null. In case of like int, it's going to be something else. Maybe it makes sense to introduce PID as a structure. And this is going to be like handle, and on POSIX it's going to be integer. And we return PID, right? So we can even have a thing. Can I just do it like that? So it's a little bit more readable, hopefully. That on different platforms is just a different thing. So we can say PID failed, and it's going to be Boolean, and we're going to accept the PID. And depending again on the platform, we're going to just like do that differently. So here on Windows, 1, 2, 3, 4, PID handle, I think it's just null, right? Isn't it? And PID handle, people suggesting define invalid PID, maybe just invalid PID, but I have a feeling that maybe the PID itself may contain something more complicated. So maybe in the future it's not going to be just PID, it's going to be like a process. So I feel like it would be better to do it like that, but maybe I'm wrong. So let's actually put P. P handle equal to like actually less than 0 or something like that. I don't know, we'll see. So this is asynchronous. Process is too long. I don't like this name. I think it's too long. Let's call it proc. Yeah, that's better. So cmd proc, and here we just return. And with that, I kind of feel like I still need this invalid thing. I kind of feel like I still need this invalid thing. And since I'm going to have this invalid thing, might as well, I don't freaking know. Like, because if this thing failed, I need to return either 0 or null depending on the platform, right? So it's just like, it's kind of dumb. So I'm not really sure how I'm gonna go about that. So I suppose I could define like invalid proc. Yeah, you see, I kind of want to define this invalid proc anyway, even if it's a structure, because it's convenient to return invalid proc out of this function in case of an error, right? So, which kind of implies that maybe I don't need a separate structure, at least for now. Yeah, okay, at least for now it would be better like that. So it's kind of difficult to tell right now. What exactly is going to be the solution in this specific case. Right, but I feel like I have a feeling that I need to come up with the correct solution right away. Not sure. Anyway, so maybe I shouldn't really think about it too much, because it kind of stalls the process of the design. Invalid proc, and this one is supposed to be CP'd, right? So supposed to be CP'd. So this is the running asynchronously, right? So in here you can proc wait, where you accept the proc, and this is where it may either succeed or not fail or something like that, right? So it may happen. So in here we had a pid wait, and I can steal the implementation from here. So the implementation for waiting on pid in Linux is kind of annoying. So, right, because you need to check, you need to keep checking, right? So essentially you start by waiting on a specific pid, right? So you're waiting on a specific pid, and then you check in the status. If that status not exited, you keep checking because it just changed the status, but it didn't really exit it. Right, it just changed the status. And I suppose here, right, so this one is going to be basically true, so that means it succeeded, but here it's going to be basically false. Right, so this thing will create an asynchronous process, right, which is basically going to run separately, right, it's going to run separately. And then if you want to, you can wait on it, right, you can wait on it, but maybe we're going to have something like start CMD synchronously, right? So you can start it synchronously, you accept CMD, and inside of this entire thing, we start asynchronously. So CMD run asynchronously CMD, and if p equal to invalid proc, we just return false, hoping that this thing will log any appropriate errors. But if it was successful, right, if it was successful, we're gonna wait, so proc wait on that thing, and if it was not, might as well just return it, right? If it wasn't successful, it's just gonna work like this. And that way, this just works, right? So that gives you basically an option. That basically gives you an option. You can do asynchronously, you can run it several threads and then basically wait on all of these processes. You can even make an array of procs and just like start a bunch of programs and append them, and then keep iterating them and keep waiting on them until they're all finished or something like that. Speaking of multi-threading, somebody was asking about multi-threading. You can already do that, right? So it's not really multi-threading, it's a multi-processing. It's more multi-processing. You can just start several asynchronous commands and that should just work. So okay, so we just need to implement this thing. So the panic is gonna be just fprintf std error, right? So it's gonna be error. All right, so I just need to go through all of these things. What I'm doing right now, I'm doing like all of that in a very C way, which has nothing to do with trying to imitate shell, actually. And that makes me feel so good, because I feel like I was limited by that idea that I must imitate shell syntactically. And I just couldn't force myself to continue working on this project because there's a lot of limitations on how you syntactically can represent this thing. And I just like feel so good not to be bound by these limitations anymore. So I'm just like using the C approach. Let's go to the compilation errors. So there we go. So this is a fork. Yeah, now we have to include all of these things. So this is a fork too. So this is a Unixy things. So we have to keep them like here, right? Because then we'll have to port all of that to Windows. So error no. This is error no. What else do we have? Okay. So sister array CMD. We don't have to do shit like that anymore, right? So exec. So this is redirection to standard inputs and standard outputs. We don't have to do that. Yeah, so we don't care about this thing. So we just fork this entire thing. Oh, and this one is interesting because here we are inside of a child process. inside of the child process, in case of an error, we must exit right away. We must exit right away. So, yep, and this one we can say that this is unreachable. So the thing about exec_vp, if exec in general, any exec in general, is successful, whatever comes after exec is never going to be executed because the current image of the process is going to be replaced with whatever we have in here. So the only reason it will go further is only because exec_vp failed. But we check that and we automatically exit out of the child process. So this particular place is literally unreachable and we need to check for that. So that probably means that there is a bug in libc. If we manage to reach this place, it's literally a bug inside of libc or even in a kernel, who knows? Right. So that means exec_vp returns success. As far as I know, exec_vp never returns a success. Is that a thing? I think it should never return a success. Yeah, exec returns only if the error has occurred. The return value is -1 and error null. Yeah, there we go. So exec can never return successfully. If it succeeded, it will just never return because the process has already replaced its image. That's a very interesting thing, by the way. Right. Successful operation in exec never returns. Never. So here we have to provide shed for exec_vp. I suppose we have to just use cmd items and then cmd items, something like this. Right. That's what we need in here. That's what we need. Let's go through the rest of the compilation. This is std error. What else do we have in here? Wait_pid. Wait_pid is located in types, so we just need to include all of these things. Okay, so I'm just like including files where all of these functions are contained. So this is going to be just p. It's a proc, it's not pid. So unknown argument gdb. Yeah, because it's a ggdb. There we go. We just successfully build Mutualizer with no build, with a new version of no build. So it worked, chat, it just worked, right? So we just executed like a compiler as a separate process. So you may say that that's a lot of code for a build script. But this is because all of that, a lot of code of starting the process has to be abstracted away into a separate library, right? So that's the point. We're basically building up the muscles of the library, right? So I'm just throwing a lot of implementations and that's going to be the library essentially. That's going to be the library essentially. So that's pretty cool. Yep. So we can think, so maybe I should call this library differently, right? Because no build is like has one particular interface. This thing is going to have its own interface. They are not compatible, so it's better not to call them the same way. So how should I call it? Let's call it, I don't know, knob. So the build system knob. Do you guys like it? Do you guys like it? It's going to be called knob. So it's a knob build system. There we go. It's a build. Knob. So it's a different thing. So you can build the commands, but to be fair, I'm not sure how exactly I'm going to code it. So I'll think about that. So we can try to maybe make a Windows build. So to make a Windows build, this is interesting. So I can try to do x86-64, right, W64, and GCC. I can do knob.c, right? And it cannot do that because, yeah, because we're trying to include Linux things. We can do the following thing. If defined win32, just include the win32 lin and min, include Windows. Is it lin and min or min and lin? I don't remember. I think it's both. I think they defined both just in case. But maybe not actually. I just realized that I don't really know. So can we do some epic scheiße like this? Oh, that's a lot. Boom. It's linen. Okay. So in case of Windows, we are just doing it like that. And we don't have a PID, right? So on Windows, it has to be completely different. But to be fair, I'm not sure if in something like wine CMD. So let's imagine that I'm inside of like wine imaginary world, right? It's an imaginary wine world. Do I have a thing there? Do I even have a thing there? Essentially, so GCC, I don't have a GCC, x86 64W64 min GW32 GCC. No, I don't have it. Right, so if I build an op for Windows, it won't be able to build anything, right? Because we have a build only specifically to cross compile, right? So that means here we need to have command line arguments, right? We need to have command line arguments through which we're gonna tell it to do the Windows build instead, right? So yes, but I'm thinking, what if we introduce like a platform? So here we're gonna have, let's create a knob library. So it's gonna be knob.h, right? So knob.h, and I'm gonna do define and if. So let's actually move everything related to the library there. Let's move everything related to the library there. So cmd run async, proc wait, and okay, there we go. So this is what we're gonna have. So this is basically the new library. This is the size of this new build library. So how many lines do we even have in here? We have 166 lines. It's the size of the logic of Visualizer, but anyway. Right, so yes, and the size of the build script specifically for Visualizer without the library is this, right? 56 lines, right? It's bigger than shell, but still not that big. So some of the things, for example, can be collapsed together, like these things. I'm pretty sure they could be collapsed like into a single thing. Who said they cannot be? And essentially what I wanted to do, I wanted to introduce like a platform. So this is going to be node.h, and it's going to be enumeration, platform, and platform Linux or Win32. And in here we're going to just accept the platform, right? So this is going to be platform, and if platform is equal to platform Windows, you're going to do it like that, and otherwise you're going to do it like that. So the cool thing of building these things at runtime, we're building command lines at runtime, is that you can build them at runtime. So you know the platform at runtime, so you can just pass this information there, and depending on the platform, it's just going to make a decision what compiler to pick in here. And we can repeat that stuff with all of these sort of like function groups of things. Right, and equal to platform Windows. And since this is like a proper programming language, I can do maybe some complicated things that allow me to discover, you know, some stuff in a system. So we can put it in here. So platform is equal platform Win32. There we go. So this is another one. Platform if platform equal platform Win32. And if I come up with something super useful in here, I can always move it inside of the build system for usage. I think this is an argument that I also made before, so I guess it's fine. So, all right, and here we have a platform, platform, and initially the platform is Linux. So, and I just pass this platform everywhere, essentially. CMD append, that doesn't matter, and that's it. So every time I build up all of these components of this thing, right, this is a new thing. So yeah, I just need to do clang platform, and I didn't put a platform in here. Okay, so that seems to be working. This is a knob. Okay, cool. So we're obviously building for Linux, right? We're using Clang, and then we're including things that are Linux. And then inside of here, I can just say, okay, so platform is Win32 now, built for Win32. And it built for Win32, right? So as you can see, it's using cross compiler, and it's just like using a different path to search for the Raylib things and stuff like that. So as you can see, I can change, okay, so Win32 or Linux, I can switch between them. So it's already like a build system, but since it's a C, I can hook it up into the command line arguments, right? So essentially, what can I say, right? So we can have the usual shift args thingy that I like to use, right? So in here, we're gonna accept the same arguments, but we're gonna accept them by a pointer. So, and in here, we're gonna assert if args has something, right? So we're gonna have a result, which is this, and then argv is gonna be the next one, and argc is gonna be -1, and we just return the result. So that allows me to pop the arguments from the left. So here I'm going to have just a program, So this is a shift args, argc, argv. So this is a program, it doesn't really matter. So, and in here, if argc is greater than 0, I can try to do, so this is by default is Linux. Then I can do something like const char subcmd shift args argc argv, and if subcmd is equal to win32, actually you're supposed to use strcmp, right? So because it's a null terminated string, you're supposed to compare it like that, because C. You basically change the platform to platform Windows. Right, Win32. Otherwise, we may try to say something like error unknown command or whatnot. Error unknown subcommand S, and this is a subcmd, and we just return 1 in that specific case. So that allows us to specify, right? So here we have knob. So this is Linux, and then Win32, this is Windows. So it's within a single program, we can switch between what we're trying to build in here. Right, so that's pretty cool. So, and this is specifically like MinGW, right? So maybe in the future we may have Visual Studio, Microsoft Visual Studio. And Microsoft Visual Studio may actually do different things here. And by the way, it actually will depend on the platform, right? So maybe this is going to be MinGW, right? So Win32, maybe here is going to be MSVC. And for different sort of platforms, you will actually implement like different implementations for these things, right? And the whole thing is going to just pick this appropriately. So, and yeah, since it's just a C program, I can easily use the refactoring techniques that I usually use in C programs, right? So if something becomes too big, I can easily create a new abstraction. A new abstraction may turn out to be super useful generally for builds, and I can factor it out into the no build. And that was kind of the point of no build initially, but then I restricted myself to trying to mimic shell syntax for some reason, and I just like didn't want to work with that. But now I don't have to do that, right? Because I don't care about anyone's opinion, right? So if you don't like this kind of style of calling external processes, like, I don't know, program in JavaScript or something, I don't fucking know. Right. This is my project, I do whatever the fuck I want. So I'm not ashamed. I'm not ashamed anymore. If I want to build my shit like that, I'm gonna be building my shit like that. Who are you to tell me how to develop my projects? I don't come to your project and tell you how to develop it, right? I don't fucking do that unless you ask me to do that, right? But I usually don't really like to do that, right? So people quite often ask me, just go review my project, tell me what you think about it. I could do that, but I really don't like to do that because I don't like to tell people how to develop their projects. It's your project, it's your territory. Like, who am I to tell you what to do? So you know what I mean? You know what I mean? It's just like, yeah. I guess that's basically the base of what I want to work with now, right? So this is going to be the beginning. We can try to port some of these functions in knob to Windows, right? So I already have Windows implementations of like starting the process and waiting for the process and stuff like that. Code roasting. So, you know, I believe that there is like one criteria. Does your code work? Does it solve the problem? So it's written correctly then. That's it. All of you shit about spaces, indentation, best practices, you can shove it up your ass, like seriously. Does the code work? Does it make money? It's fucking good. That's it. Right. All of the other arguments are for losers. Like I'm telling you. I'm fucking telling you. It's just like I'm so tired of it. I've been in these kind of conversations for so many times over 17 years I've been programming. It's just like, it's so tiring. Just solve the goddamn fucking problem. Does the code solve problem? It's fucking good enough. That's it. End of the conversation. I have one file and one class for the whole project. Does it solve the problem? Does your project work? Right. What your project does. Like, I really don't give a shit how many classes you have. What's your project is about? Right. So don't tell me how many classes your project has. What your project is doing. That's the most interesting thing. Does it solve some interesting problem? Maybe it has some sort of interesting visualization, or it does not. That means it sucks and it has nothing to do with a single class. You see? Right. So that's the real roasting of the project, right? And I don't care. I don't care if it's a one class, two classes, or it's a procedural function. I don't care. Does it do anything? It doesn't do anything. Well, why it doesn't do anything? Maybe this is because you spend too much on thinking about whether you need to have one class or two classes instead of actually solving problem. Maybe that's the reason. My face is red now. I'm sorry. I didn't mean to. Look, I mean, I roasted your code without even seeing it. So yeah, my advice, don't think about it too much. Don't think about it too much. Write something that actually does something, that puts something on the screen, that allows you to interact with that something on the screen, right? And as soon as you have something interesting, you can then see what kind of problems you have and you can solve those specific problems. Right, so people get caught on solving imaginary non-existing problems all the time. So I have 0 classes and my code does many things. It's just like a Linux kernel. How many classes does Linux kernel have? It doesn't have a single class. Is it a useful piece of software? Well, probably. I'm using it right now. I'm using it right now. Okay, guys. So I guess that's it for today. Thanks everyone who's watching me right now. I really freaking appreciate that. Have a good one, and I see you all on the next recreational programming session with Azuzin. Love you. Mwah.